January 19th, 2006. An Atlas V rocket, a 212-foot powerhouse, is prepped for launch at Cape Canaveral.
It was one of those days where you say to yourself, this is it. Project succeeds or fails today. Because when things go bad on launch, they usually go bad in a spectacular way.
T-minus 5, 4, 3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a voyage to visit the planet Pluto and beyond.
It's the fastest launch ever recorded, 36,000 miles per hour. New Horizons needs all the speed it can muster on a journey that will take it clear across the solar system to attempt something unique in the history of spaceflight. Get an up-close and personal look at Pluto, a mysterious, distant world unlike anything we've explored before. Back on Earth, at the Johns Hopkins Applied Physics Laboratory, the mission operations team for New Horizons is not quite ready to celebrate.
Once the rocket took off, there's a great feeling of joy. And then you hold your breath for a while, because you're not done until you get the signal back from the spacecraft that everything's okay.
We don't have a mission until we know that spacecraft is communicating with us.
And so, they wait.
Everything is a concern. It's the things we've thought about, we know we've solved. To try and anticipate so many eventualities, it's the challenge of spaceflight.
Almost an hour passes. And then, Mission Ops receives the first signal from New Horizons.
Scientists turn to each other and go, "I love you, man." It was an astonishingly happy time.
And that's the greatest feeling, because now we know we have a mission to Pluto.
This is just the first of many challenges to come on a journey that will take almost a decade.
Just 9 hours after leaving the launch pad, it was already crossing the orbit of the moon.
A trip that took Apollo astronauts 3 days. But even traveling tens of thousands of miles an hour, it will take over 9 years for New Horizons to reach its destination, to explore the far reaches of our solar system. More than 3 billion miles from Earth. Beyond the planets we've come to know. Mars, with its rocky red surface. The gas giant Jupiter, with its raging storm. And Saturn, with its stunning rings. Uranus, where turbulent winds blow over 500 miles an hour. And Neptune, a planet so far from the Sun, it takes 165 years to complete just one orbit. Finally, New Horizons will arrive at Pluto, a world we can only picture with the help of artwork like this. At least for now.
Who can tell us more about the planets?
Back in the 1950s, every grade schooler was taught there were 9 planets, Pluto being the last and loneliest.
Everybody loved Pluto because it was this funny oddball sitting out there at the very edge.
You don't find that kind of name recognition and emotional connection and interest level for Uranus or Mercury or going down the list, but somehow Pluto just naturally attracts people's attention.
What makes Pluto so popular? It may have something to do with a playful bloodhound named Pluto the Pup. It turns out the Disney character made its debut around the same time the planet was discovered. Over the years, we've gotten to know this beloved little pup. The same can't be said for this mysterious little world. The truth is, Pluto and its moons have only been observed from billions of miles away. Our best images, nothing more than a blur. In fact, one of the biggest, baddest space telescopes in our arsenal, the Hubble, which takes stunning images of enormous distant galaxies, can only capture these pixelated images of Pluto Because not only is it far away, it's really small. But even at this resolution, they suggest something intriguing. Using these precious pixels, a computer-generated image reveals Pluto has a surprisingly varied surface. The light areas could be miles and miles of ice.
The ices are the most obvious signature that you see, but you can discern that there's other components there as well. We just don't know exactly what they're made of.
But here's what we do know. One of the few planets in the solar system with such a varied surface is planet Earth. We also know that Pluto has a rather bizarre atmosphere. During its 248-year orbit, as Pluto gets closer to the Sun, its frozen surface starts to thaw, and its atmosphere slowly emerges.
What we see in the atmosphere is gases that are coming off the surface, creating a temporary atmosphere, perhaps. Pluto has a unique type of atmosphere in this outer part of the solar system that we've never studied before.
An area so distant and elusive, we knew almost nothing about it until the 1990s, when powerful new telescopes discovered lonely little Pluto wasn't so lonely after all. It's part of a region in the outer solar system beyond the orbit of Neptune, called the Kuiper Belt, and it is enormous. Billions of miles from the Sun, the Kuiper Belt is filled with hundreds of thousands of icy objects. While they may look like asteroids, which are made of rock and metal, these objects, hidden in the solar system's deep freeze, are made of a mixture of rock and ice.
These are basically frozen remnants of the early part of the solar system that are still in the freezer. You can start to read this fossil record of how the solar system evolved by looking at these objects.
You can't say for the New Horizons mission, been there, done that, because it hasn't. We've already explored the terrestrial planet region, the giant planet region. Now we're exploring a completely new portion of the solar system that's never been touched before.
We don't know what we're going to find. We really don't. And I think that that's what really makes this so exciting.
How do you design a spacecraft that can survive a 3 billion-mile journey to parts unknown?
Anytime you explore something new, there's always a little risk.
The New Horizons mission faced a huge number of challenges. We're going to the outskirts of the solar system, 30 times farther from the Sun than the Earth. And so, in order to get there in a reasonable amount of time, we had to build the lightest possible spacecraft that we could, put it on the largest rocket we could. There was no opportunity to fly big solar arrays because the sunlight is just too faint. So we carry a nuclear-powered source. We have a suite of instruments, 7 instruments, to do very different things, and they weigh less than about 70 pounds, all of them together.
7 scientific instruments, not much bigger than a grand piano, with whimsical names like Pepsi, Swamp, and an antenna named Rex. 2 are named after the lead characters in the 1950s television show The Honeymooners, Ralph and Alice. All of these instruments will analyze Pluto's surface and geology and reveal secrets about its mysterious atmosphere. Back in the 1980s, one of the best ways to observe Pluto's atmosphere was with this: a C-141 cargo plane with a makeshift observatory on its side. The Kuiper Airborne Observatory was not what you'd call a first-class ride.
The Kuiper Airborne Observatory is not built for comfort. You're on headsets the whole time. It's very loud. It's very cold. The telescope, it's in the middle of an airplane. It bounces around.
But by flying a telescope above the weather, they had a chance to capture a rare event called a stellar occultation. During this event, an object like Pluto passes in front of a bright star blocking its light. If the object has an atmosphere, the light gradually fades out, then slowly fades back up again. But if it doesn't, the light abruptly disappears, and then quickly reappears. This is a recording of what happened on board the Kuiper Airborne Observatory the night of June 9th, 1988, when a group of researchers were determined to find out if Pluto has an atmosphere.
I think it's fading. It's fading. Well, it's faded on the tracker. Yeah, it's faded here. Yeah, I think it's faded here, too. Wow, okay. I think that thing has an atmosphere, guys. Yeah, atmosphere.
The light behind Pluto slowly faded, and the crew made history.
I was fortunate enough to be involved. I would call that the beginning of my being an astronomer. And it's a pretty good beginning.
One of the instruments on board New Horizons that's designed to study Pluto's elusive atmosphere is ALICE.
This model is an actual size model of ALICE. ALICE is an ultraviolet spectrometer. It's a telescope that breaks up light into a rainbow.
Every chemical element reflects and absorbs light in a unique way, creating a pattern as distinct as a fingerprint. Hydrogen's fingerprint looks like this, while nitrogen's looks like this. Powerful Earth-based telescopes have already detected molecules of nitrogen, methane, and carbon monoxide on Pluto's surface and in its atmosphere.
We suspect it has a number of others that we simply can't detect.
As the spacecraft flies just a few thousand miles above Pluto, ALICE will search for those fingerprints. Then, at the end of the flyby, the spacecraft will turn around to give ALICE a one-of-a-kind view of Pluto's atmosphere, as seen through the light of the sun.
We can use the sun as our light source to probe the atmosphere and look for those fingerprints of certain types of atoms and molecules.
While ALICE probes Pluto's atmosphere, her partner, Ralph, an infrared spectrometer, will be hard at work searching for those chemical fingerprints of molecules on Pluto's surface.
We want to know what's causing the very bright surfaces on Pluto, which we think is exotic snowflakes of molecular nitrogen and methane. But there are other regions that seem to be devoid of those snowflakes and are probably much redder, darker hydrocarbon deposits.
Ralph will finally reveal what these strange, dark regions are made of. But to get up-close and personal images of Pluto requires an instrument with a one-of-a-kind telephoto lens. The largest imager on board New Horizons, named Lori, will capture extraordinary images of Pluto's surface. Lori will take pictures so detailed that if it was flying over New York City, you could see the Hudson River, the East River, even Central Park. To put this in perspective, this image of the Big Apple was taken by a satellite traveling about 400 miles above Earth. Lori is so powerful, it could capture the same amount of detail from more than 7,000 miles above Earth. But sending a telescope with a lens like this into the grueling sub-zero temperatures of the Kuiper Belt is risky business.
When you have a telescope, it's opened to space, and so it's cooling through that opening. The result is that you're putting part of the camera cold, part of it warm, and that changes the shape of the telescope, and that tends to put it out of focus.
And you can end up with pictures that look like this. To solve this problem, they turn to a material found in bulletproof vests. What makes vests like this so strong is a compound called silicon carbide.
Lori is made out of a special version of it, which is able to tolerate temperature gradients without distorting its shape. But it's also very strong and very light.
There's a lot of things that might go wrong, and we've tried to anticipate all those things and work out contingency plans and contingency plans for those contingency plans.
We've been working for years to get the spacecraft ready, prepared for everything you could think of. In the end, it just, you just have to sit there and wait, and it just either works or it doesn't.
For the New Horizons team, waiting to find out if all their hard work will pay off, just maybe the toughest challenge of all.
During the Pluto encounter, the spacecraft's basically pre-programmed to do everything on its own.
If it gets into trouble, we can't help. We can't give it a call and say, whoops, you're looking at the wrong thing. Adjust your sights a little bit to the left.
That's because when the spacecraft flies by Pluto, it will take 4.5 hours for a radio signal to reach Earth, and another 4.5 hours for instructions to get back to the spacecraft.
If something went wrong, it would be more than 9 hours before we could tell it to do something. The most important science is happening really only over about a 12-hour period.
The timing has to be precise because the onboard commands all have a predetermined time that this is supposed to happen. If that time changes too much, we'll get a lot of pictures of black space, and we'll miss the science.
February 28th, 2007. New Horizons has been en route for a little over a year. Back at mission operations at the Johns Hopkins Applied Physics Laboratory, the team prepares for the spacecraft's first real test since launch. As New Horizons nears Jupiter, it must hit a mark just 500 miles wide, where it will get pulled into the gas giant's gravity and get flung out. At that point, it will be traveling a lot faster. Think of it like a clever maneuver used in roller derby, called the whip. One skater pulls another, propelling her forward with greater velocity. That's what Jupiter's gravity will hopefully do for New Horizons. At mission operations, the tension is palpable, especially for the mission operations manager, Alice Bowman, also known as Mom.
Status check.
She has spent years preparing for this moment, and she knows all too well what it means if this maneuver should fail.
It would take years longer to get to Pluto if you did not have that flyby.
If you think 9 years is a long time, adding another couple years onto that, that would have been intolerable.
The clock is ticking. Mom, along with the mission ops team, waits to receive telemetry from the spacecraft. This data will reveal whether New Horizons successfully pulled off the gravity assist or not.
Red is bad, green is good, gray means you don't have any data.
Finally, they hear from the spacecraft.
PI, this is Mom on Pluto 1. Spacecraft telemetry for all subsystems is nominal. Spacecraft is outward bound from Jupiter, and we're on our way to Pluto.
All right.
So far, so great. This is good.
By stealing some momentum from Jupiter along the way to Pluto, we can actually increase the speed of the spacecraft by about 20% and cut 3 years off the travel time.
At the same time, because in order to do the Jupiter flyby, you end up coming fairly close to it, it gives you an opportunity to do some great science.
It was the only time we were going to have large objects for the cameras to actually point to and say, okay, are we doing this right?
We used all the instruments on New Horizons, but Lori was prominent.
Okay, there she was. Oh, wow, look at that.
Oh, yeah.
And we got both of them. We got both of them. Okay, all right.
It's beautiful.
From more than 1 million miles away, Lori captures a sequence of images of the eruption of a volcano on Jupiter's moon, Io.
It was the first time that time-lapse had ever been made of any volcano anywhere in the universe off the Earth. So it was really unique.
It's another plume.
Oh my gosh. Look, very perfect image.
Yeah.
We were extremely lucky. We got these fantastic movies. It made all those sleepless nights and all that hard work very much worth it.
After the gravity assist, New Horizons goes into hibernation. Only essential systems are up and running. This limits the amount of wear and tear on the equipment. For most of its 9-year journey, it will be asleep. But once a week, the spacecraft phones home to Mom.
CDH, this is Mom on Pluto 1, status check.
And Mom lets the whole team know if all systems are in working order. As New Horizons makes its way across the solar system to the last and loneliest planet to be explored, back on Earth, a revolution in astronomy is taking place. After 75 years as the solar system's 9th planet, Pluto is getting its walking papers.
Pluto was, since 1930, a planet. He had stature, he had friends.
Could it be the final indignity for the farthest and smallest planet on our solar system?
Rock on Pluto, you'll always be a planet to me.
The public takes to the streets to fight for Pluto. It's been America's favorite planet since it was discovered back in the 1930s by the unlikeliest of planet hunters. Clyde Tombaugh was a self-educated farm boy who attended a one-room schoolhouse. His first job in astronomy included cleaning telescopes and sweeping up at the Lowell Observatory. He spent the rest of his time searching for something that could be causing disturbances in Neptune's orbit: the mysterious Planet X. Every few nights, he placed a photosensitive glass plate on the telescope, securing it so it would not shift. Then he exposed the plate for 1 hour to the universe. During that time, the motorized telescope slowly moved to compensate for Earth's rotation. Several days later, he'd retrace his steps, taking pictures of the same sections of the sky he had photographed earlier. Then, using an ingenious device called a blink comparator, Clyde aligned the two images to carefully examine their differences. The blink comparator enabled him to shift back and forth, searching for the subtlest of changes. Although the human eye is good at spotting differences, finding a dim celestial object billions of miles away was a daunting task. Month after month, he forged ahead through a harsh, cold winter.
He almost froze to death one night because his fingers got so numb he couldn't get the trap door open to get out of the dome. They were having a lot of problems with the photographic plates breaking in the cold weather, and he invented a new plate holder that would keep the plates from breaking, and that's what led to the discovery.
After patiently searching for almost a year, a determined Clyde finally found a tiny dot, slowly moving across the night sky. Can you see it? Here it is. Two months later, the Lowell Observatory proudly announced that a young assistant had discovered the 9th planet in our solar system.
Because of the discovery, my dad got his college education. Otherwise, he probably would not have been able to afford to go to college. The discovery was, I would say, the driver of our life in many ways.
After discovering Pluto, Clyde taught astronomy, and for decades to come, he searched for another planet in the far reaches of the solar system. But as hard as he and other astronomers looked, and they looked hard, nobody found anything. Until astronomers David Jewett and Jane Liu took on the challenge. They started a search that would take a lot longer than they could ever imagine.
Why did it take so long? It was a matter of technology catching up with the problem.
While it's easy to see distant stars because they radiate light, other celestial bodies are much harder to see. That's because light has to travel all the way from our sun to the object, reflect off its surface, and then make the long journey back to Earth. By then, it's barely visible. David and Jane hope that advances in digital detectors, now standard in today's smartphones, would help them see a whole lot more. After searching for 5 years, they finally found something.
Here is the set of discovery images for the first object. So you can see this object drifting from this picture to this one, is drifting slowly to the left.
When they found several more of these slow-moving objects, David and Jane could finally declare Pluto is not alone. In fact, it's got plenty of neighbors. They named this new region of the solar system the Kuiper Belt, after Gerard Kuiper, the astronomer who proposed its existence back in the 1950s. The discovery of the Kuiper Belt expanded our understanding of the solar system in a profound way. But it also put Pluto's planetary status in jeopardy. Is it a planet or a Kuiper Belt object? One of many.
My dad knew there were rumblings in the wind, and it upset him. It certainly was not easy for my father.
But the final blow was yet to come. A few years later, a young astronomer decided to look for more objects in the outer solar system. Mike Brown was determined to do something really big. Find a Kuiper Belt object larger than Pluto.
We even thought we might be finding things the size of Mars, the size of the Earth. We really had no idea. So when we started off doing this back in 1997, it was pretty exciting to think what might be out there.
At the Palomar Observatory in California, Mike had access to the largest digital camera on Earth. The images were uploaded to his computer, where he analyzed them every morning. With technology on his side, the discoveries just kept on coming.
We found Quarwar, which is an object out in the Kuiper Belt that's about half the size of Pluto. The next year we found something about 3/4 the size of Pluto. And in the following year we found this thing, and it was so bright and also moving so slowly. Moving so slowly because it was so far away.
After all this time, Mike couldn't believe he might finally have found what he had been looking for.
I looked at it and I thought, this can't be right. If it's that bright and moving that slowly, it's the furthest thing we've ever found. And it's the biggest thing we've ever found, and it must be bigger than Pluto, and that's crazy.
It was the first object to be discovered that could have been larger than Pluto. That caused a ruckus because, well, if Pluto's a planet, then this has got to be a planet, right? And so what are we going to call all these things?
Most people really didn't care that much about this thing that we had just discovered. They wanted to know, well, what does it mean for Pluto? It's like, oh yeah, you found something bigger than Pluto, but what does it mean for Pluto?
For the past century, the IAU, the International Astronomical Union, has been in charge of naming celestial objects. But it couldn't give Mike's discovery a name without knowing if it was a Kuiper Belt object or the 10th planet.
I think it started an interesting conversation because we didn't really have a definition for planets, okay? You know, came from the Greek wandering star. And we did need a better way of classifying things as being planets or small bodies in the solar system.
At the IAU meeting in Prague, a vote was taken on a new definition of the word planet. Pluto's fate came down to the phrasing of just one line. A planet has cleared the neighborhood around its orbit. Pluto resides in a crowded neighborhood filled with thousands of Kuiper Belt objects. Unlike larger planets, tiny Pluto doesn't have enough gravity to clear them out of its way. It also has an extreme elliptical orbit, not on the same plane as the rest of the planets.
8 major things which dominate the solar system are planets. They're all big, they go in circular orbits in one disk around the sun, and everything else is much smaller. Those are not planets.
So according to the IAU, Pluto is not a planet. It's a dwarf planet.
There has been a consensus developed that Pluto is a dwarf planet. And, you know, I have no problem with that. The controversy comes in when you try to say a dwarf planet is not a planet. Well, it seems a little ridiculous to have the planet in the word, the designation for an object, and say somehow it's not a planet.
And in a sense, this question of how do you label certain objects is less important than understanding that objects like Pluto, the Earth, Jupiter, exoplanets come in a remarkable variety, in remarkably different configurations across the universe.
While Pluto may no longer be the solar system's 9th planet, it turns out it's got plenty of company. Planetary scientists continue to discover more dwarf planets, giving them temporary nicknames like Santa and Easter Bunny.
We've discovered that the outer solar system is littered with small planets. These are typically rocky and icy objects. Many have atmospheres. Many, possibly most, have moons. All the things we're used to in the planets we're familiar with, but in miniature. I think a decent analogy is when you see a Chihuahua, it's still a dog, because it has the characteristics of the canine species, just in miniature.
Not everyone agrees with Alan Stern's canine analogy. And as more Kuiper Belt objects are discovered, the question arises, how did our outer solar system end up with these pint-sized dwarfs? To answer that, we may need to look back at the birth of the solar system.
We think that the solar system began to form about 4.5 to 4.6 billion years ago, when a cloud of nebula, a cloud of gas and dust, fell in on itself because of its own gravity. As it fell together, it began to turn into a great disk of orbiting, swirling material. It's that disk of gas and dust that we think turns into planets. You make a planet from material sticking together and building larger and larger pieces.
Scientists theorize that planets form when this material starts to stick together. Pebbles turn into boulders, boulders into mountain-sized comets. Comets turn into protoplanets. Protoplanets turn into planets.
After objects reach a certain threshold in their mass, they can grow more rapidly than they could before because they have substantial gravity.
Gas giants like Jupiter and Saturn siphoned up massive amounts of hydrogen and helium, sweeping up everything in sight.
It seems plausible that Pluto originally formed somewhat closer into the Sun, but then as those major planets got larger and larger, it got pushed to a more distant orbit. We think that objects like Pluto and the other Kuiper Belt bodies are really the remains of that process of planet formation.
They are sometimes called planetesimals, celestial objects that somehow stopped growing.
Dwarf planets were arrested in the mid-stage of planetary growth. They are actually planetary embryos, and to study those objects rather than objects that grew to much larger scales will give us a great window into the process of planetary formation.
Perhaps we can find clues in the surface of Pluto and its composition that point towards that deep history and in turn tell us about the architecture of the solar system as it is now. Where did that come from? How did that happen?
Pluto may even hold clues to unravel another great mystery. As far as we know, the requirements for life are water, energy, and organic matter. A large number of dwarf planets may have all of these ingredients.
There are very reputable models of Pluto that suggest that there's a vast interior ocean, and that these may be common inside the dwarf planets. Wherever you have water, then you have the potential, and I want to stress that word potential, for biology. So it may be that the dwarf planets are not only the most common kind of planet in the solar system, they may be the most common abode for life in the solar system.
Clearly, organic chemistry, carbon chemistry can take place on the surface of objects like comets and probably Kuiper Belt objects too. Whether or not that relates to the existence of life on Earth, I think is a totally open question. But just understanding the chemical richness of our solar system and the universe is a big piece of the puzzle, and it's a piece of the puzzle that we need to solve.
June 8th, 2008. New Horizons has been soaring through space for more than 2 years. Today, it passes the orbit of Saturn. In 3 more years, it passes Uranus. It spent half a decade traveling through space, and it's still running like clockwork. But then, the unexpected happens, putting the entire mission at risk. Images taken by the Hubble Space Telescope reveal Pluto has not 1, not 2, not 3, not 4, but 5 moons.
All of these moons probably all formed in the same big cosmic collision taking place about 4.6 billion years ago, where 2 Pluto-sized objects rammed into each other, and now we're seeing the aftermath of that.
In the end, Pluto remained intact, but the other object broke into pieces, forming the 5 moons that we know of, some very oddly shaped.
All of these small moons are debris generators creating the potential of millimeter-sized dust forming a ring around Pluto. The spacecraft is flying so fast through the Pluto system, roughly 30,000 miles per hour, that if it hit even a millimeter-sized particle, it could blow a hole in the spacecraft and it could destroy the mission.
Back in 1967, this almost happened to the Mars probe Mariner 4.
It ran into a cloud of space dust, and over the course of about 45 minutes, they were seeing thousands of impacts on the spacecraft, completely unexpected. Clearly, there are particles out there that we can't detect that could potentially cause a loss of mission.
How much of a beating can New Horizons take? We're about to find out at one of the most powerful shooting galleries in the world. NASA's hypervelocity gun can shoot the tiniest of pellets up to 17,000 miles per hour. The dust particles New Horizons might run into range from the size of the head of a pin down to the size of a grain of sand. These little objects may not look very dangerous, but imagine a sandstorm with winds so strong that just one grain of sand could kill you. The gun is loaded. The room is cleared. This gun is so powerful, metal is pulverized from the impact. A pellet is propelled down this 120-foot-long barrel to a target made of the materials used in the construction of the spacecraft. The first layer is the gold thermal blanket that covers New Horizons. The second layer is the spacecraft's wall. The third layer, a thin metal plate, represents the heart of the spacecraft, the electronics and scientific instruments. Test after test is conducted. Tiny pellets slammed into the target at lightning speeds. The results are mixed. Most of the pellets penetrate the gold thermal blanket, but are stopped by the wall of the spacecraft. But not all. In fact, some, like this one, punch a hole right through it. A few more holes like this could put a quick and violent end to the mission.
The potential for a debris impact that came out through the detection of the newer moons does add another layer of complexity to the flyby.
The New Horizons team had to come up with alternate flight plans, or trajectories, for the spacecraft to travel. This is the ideal trajectory they're hoping for.
There are actually 4 different trajectories that we could potentially go on, and we may not know until a couple of weeks out which one we're going to be on.
The worst possible scenario is it comes into the system, it starts taking images, it gets destroyed by some impact, and we'll never see the images, which is pretty nerve-wracking. I want to see the results. I'm glad I'm not the person waiting for that data to come.
On the approach, we have planned observations to look for any other debris, or we're calling them hazard now, not moons, hazards. It's funny how things change.
Will always be a little nagging question. Did we make it through? So that first beacon that says we made it through, everybody is just going to, they'll breathe a sigh of relief, and then they'll look at each other and go, oh, I knew it all.
August 25th, 2014. New Horizons reaches Neptune's orbit on the 25th anniversary of Voyager 2's encounter. The original mission was designed to study only Jupiter, Saturn, and their moons. But Voyager 2 went on to take stunning images of Uranus, Neptune, and its moon, Triton.
In the 60s and the 70s and the 80s, we were exploring new planets all the time. First to Mars, first to Venus, first to Mercury, first to Jupiter, first to Saturn. That came to an end in 1989 with Voyager. It's been 25 years. And now we're doing the next first mission. That's epic.
December 6th, 2014. After years in hibernation, the spacecraft is waking up. The final leg of its journey is about to begin.
Tonight, we're ending hibernation. We have been hibernating the spacecraft for most of the 3 billion mile journey across the solar system. That's over now. It's really quite a historic day.
Once the spacecraft has checked that all systems are up and running, it will send a report back to Mom.
So when we receive signal from the spacecraft, it's data that the spacecraft sent 4.5 hours earlier.
And it requires a special network of radio antennas to receive it. These enormous antennas are spaced across the globe, so as the Earth rotates, the team can stay in touch with the spacecraft 24/7.
The spacecraft has a 10-watt transmitter that we can pick that signal up on Earth, which is incredible.
In comparison, your average radio station uses 50,000 watts to transmit a signal.
It is an amazing accomplishment, and it's a lot of that's due to the technology that's at the stations, at the Deep Space Network, these amazing antennas.
Getting ready for showtime here.
A few members of the team have gathered in the room next door, hoping to celebrate. But that moment will only arrive when a very tense mom gets word from NASA's Deep Space Network that they are starting to receive a signal from New Horizons. Data begins to show up on her screen.
Did we get it? We got it.
But before she can breathe easy, all members of the Mission Ops team must verify that all systems are in working order.
RF Mom on Pluto 1, status check.
RF is green.
Power, status.
Power system is green.
Propulsion, status.
Propulsion is green.
There we go.
We have a nominal wake-up of the New Horizons spacecraft on our way to Pluto. The team is ready for the next leg of our journey.
We got an encounter coming. Yeah. Yeah. How about that?
Some days it just goes like clockwork.
Here we go. Here. Cheers.
And I'll take a big breath now.
To Pluto and beyond.
You're here.
To history.
History. This has been a very long road.
It's for the mom.
Yes, okay.
Okay, thank you.
Well, it's just amazing. We are on the other side of the solar system, and where we were meant to be.
When we talk about the spacecraft, we talk about it as if it's, you know, our child, our baby. When it does something that we don't expect, we relate it perhaps to terrible twos or something like that. So it really becomes part of us.
Over the years, hundreds of people have dedicated themselves to this historic mission. For many team members, revealing Pluto's secrets is the challenge of a lifetime.
The New Horizons mission has been a large part of my life, and it's been the majority of my children's lives. I think they can't even imagine what it'd be like to have this data from Pluto, because they've been looking forward to it for their whole life.
As New Horizons gets closer and closer to Pluto, the team determines there are no more moons and little risk of the spacecraft being destroyed by debris.
They looked and they looked and they looked, but they couldn't find any new moons. I think they were kind of disappointed from a scientific standpoint, but from a hazard standpoint, it was really good news.
But the good news is short-lived.
About 1:55 p.m. local, we've lost signal with the spacecraft. You just feel that pit in the bottom of your stomach. You're thinking, oh my God, I can't believe this is happening.
Your pulse goes up a little bit. Could it be, these millions of miles away, he hit something?
Searching for a solution, Mission Ops tries to connect with New Horizons' backup computer, which transmits on a different radio frequency.
Right away, Deep Space Network locked up onto that signal, and it was such a great feeling because we found our spacecraft.
It turned out that the main processor had reset, and it switched over to the backup processor. That's sort of like the worst nightmare a week before an encounter.
We knew that we could fix it. The question was, were we going to be able to do that in enough time?
Alice, I swear, didn't get any sleep, but she said she slept on the floor for a few minutes one night.
For a couple nights, slept there, just like a child that's sick. You want to be there to help it recover along the way.
The team fixes the problem just 7 days before New Horizons is set to fly by Pluto.
We did it with 4 hours to spare or something like that.
Yes, things are definitely back on track.
And the pictures are flooding in.
Every day it's been getting better and better. We've been getting beautiful stuff for the last week. We are drooling with anticipation.
The next picture from Lori that we will see is a full-frame image of Pluto, and it's the one that we think is really going to tell us what's happening. I almost can't wait for it to come down.
Taken from almost 500,000 miles away, this is New Horizons' last portrait of Pluto before its closest approach. Scientists speculate that the light areas are ice. The dark could be a dusting of organic molecules that fall from the atmosphere.
Wow. And this is the heart, right? This is the this is the heart-shaped region.
Yeah.
Being traced out here.
Clearly, there's a lot of craters.
Yeah.
Boy.
Really is, breathtaking and awe-inspiring.
I've never seen anything like this before.
But there's one more hurdle, and it's a big one. The world watches as the team tensely awaits a signal from New Horizons that it has made its closest approach to Pluto, less than 8,000 miles above the surface, and survived with all systems intact.
Stand by for telemetry. PI, Mom on Pluto 1. We have a healthy spacecraft. We've recorded data of the Pluto system, and we're outbound for Pluto. We did it.
Very relieved and happy. Yes.
No, I mean, every polling that was done, every subsystem that reported in was like music to my ears. It's never sounded that good.
The next day, the tiny spacecraft, 3 billion miles from home, starts beaming back. The first close-up pictures of Pluto with icy mountains 11,000 feet high. And Pluto's biggest moon, Charon, with hardly any impact craters. It will take about 16 months for New Horizons to send back all the photos and data it has gathered, and years for scientists to analyze it, slowly revealing Pluto's secrets as New Horizons itself heads out through the icy Kuiper Belt and beyond its destination to explore the far reaches of our solar system, more than 3 billion miles from Earth, beyond the planets we've come to know. Mars, with its rocky red surface, the gas giant Jupiter, with its raging storm, and Saturn, with its stunning rings. Uranus, where turbulent winds blow over 500 miles an hour. And Neptune, a planet so far from the Sun, it takes 165 years to complete just one orbit. Finally, New Horizons will arrive at Pluto, a world we can only picture with the help of artwork like this, at least for now.
Who can tell us more about the planet?
Thought about, we know we've solved. To try and anticipate so many eventualities, it's the challenge of spaceflight.
Almost an hour passes. And then, Mission Ops receives the first signal from New Horizons.
Scientists turn to each other and go, "I love you, man." It was an astonishingly happy time.
And that's the greatest feeling, because now we know we have a mission to Pluto.
This is just the first of many challenges to come on a journey that will take almost a decade.
Just 9 hours after leaving the launch pad, it was already crossing the orbit of the moon.
A trip that took Apollo astronauts 3 days. But even traveling tens of thousands of miles an hour, it will take over 9 years for New Horizons to reach. Back in the 1950s, every grade schooler was taught there were 9 planets, Pluto being the last and loneliest.
Everybody loved Pluto because it was this funny oddball sitting out there at the very edge.
You don't find that kind of name recognition and emotional connection and interest level for Uranus or Mercury or going down the list, but somehow Pluto just naturally attracts people's attention.
What makes Pluto so popular? It may have something to do with a playful bloodhound named Pluto the Pup. It turns out the Disney character made its debut around the same time the planet was discovered. Over the years, we've gotten to know this beloved little pup. The same can't be said for this mysterious little world. The truth is, Pluto and its moons have only been observed from Bill Yeadkin Muster on a journey that will take it clear across the solar system to attempt something unique in the history of spaceflight. Get an up-close and personal look at Pluto. A mysterious, distant world, unlike anything we've explored before. Back on Earth, at the Johns Hopkins Applied Physics Laboratory, the Mission Operations Team for New Horizons is not quite ready to celebrate.
Once the rocket took off, there's a great feeling of joy. And then you hold your breath for a while, because you're not done until you get the signal back from the spacecraft that everything's okay.
We don't have a mission until we know that spacecraft is communicating with us.
And so, they wait.
Everything is a concern. It's the things we
January 19th, 2006. An Atlas V rocket, a 212-foot powerhouse, is prepped for launch at Cape Canaveral.
It was one of those days where you say to yourself, this is it. Project succeeds or fails today, because when things go bad on launch, they usually go bad in a spectacular way.
T-minus 5, 4, 3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a voyage to visit the planet Pluto and beyond.
It's the fastest launch ever recorded, 36,000 miles per hour. New Horizons needs all the speed